This video is about factoring three-term quadratics where the leading coefficient is not 1. Let's get started. This actually is our last factoring method or tool we have to factor polynomials. We've talked about binomials, we've talked about four-term polynomials, and now we're finishing off with three-term polynomials where the leading coefficient is not equal to 1. For all of these factoring methods, we will always start with the GCF. So first, factor out the GCF if possible. If the polynomial is a three-term quadratic with a, the leading coefficient, not equal to 1, then we'll use the ABC method to rewrite as four terms, and then we'll do factor by grouping. Okay? So we will first, again, check for the GCF. We will look at A times C. Now, it's very important you don't miss this step. Okay? Before, you could use just C if A is equal to 1. Now, A is not equal to 1, so you must multiply A times C. Okay? And you're looking for the two factors of this product that will add up to be B. Okay? And then you break it up in that B term into two terms, and then use factor by grouping. Okay? Let me show you a couple examples of that process. Okay, in example 1, we're trying to factor 12x squared plus 13x minus 4. Okay? First of all, is there a GCF? No, there's not, because 13 is prime. Okay? There's no GCF. Is it a three-term quadratic? Yes, it is. It's a three-term quadratic. Okay? Does A equal to 1? No, this first term, leading coefficient, is not 1. It's 12. So I'm going to have to use the ABC method specifically to multiply A times C. So A times C is 12 times negative 4, which is negative 48. Okay, and negative 48 has quite a few factors. So let's be methodical about how we look at these factors. Okay, I'm looking for two numbers that will multiply to be negative 48 and will add to be 13. Okay, positive 13. So I'm looking for two numbers that will multiply to be a negative, and that happens when I have a negative and a positive. Okay, so I'm looking for a negative and a positive number that will add together to be a positive 13. That means that the bigger number has to be positive. So I'll keep that in mind. I will have negative 1 and positive 48. I have negative 2 and 24. I have negative 3 and 16. I have negative 4 and 12, negative 6 and 8. Okay, those are all my factors of 48, where the bigger number is positive, so that when I multiply I get negative, but when I add I get positive. Do any of these add to be 13? Well, yeah, this pair right here, this negative 3 and 16 will multiply to be 48, that A times C number, and it will add to be 13. So I'm now going to use those two numbers to rewrite this. Okay, I'm first going to just be super clear. I'll write 12x squared. Okay, and then I'm going to rewrite this 13x as minus 3x plus 16x. Okay, which again, it does, that is equal to 13x. I'm just expanding it into two different pieces, which will be very helpful for us later on. And then I still have my minus 4. Okay, those didn't change. Just that middle term got expanded into two parts using this pair that I found. All right? Once you've done that, we will then do factor by grouping, which we've already learned in a previous video, okay? If you're not sure, then go back and watch that previous video again. But I'm looking at these two terms as a group and these two terms as a group. Okay, and I will pull out the GCF, the greatest common factor, in each group. So 12x squared minus 3x, the GCF there is 3x. Okay, so 3x times what is 12x squared? And the answer is 4x. And 3x times what is negative 3x? And the answer is negative 1. All right, and then the GCF between positive 16x and negative 4 is going to be, let's see here, plus 4. Okay, 4 times what is 16x? And the answer is 4x. 4 times what is negative 4? And the answer is minus 1. Okay, notice from factor by grouping that what I want to have happen is these to be the exact same, and that happens here. And as long as you find the correct values that multiply to be a times c and add to be b, it's always going to work out. So I then bring that common factor, the 4x minus 1, to the front, and then I get 3x plus 4 as my two factors. Okay, so that's the ABC method. It is pretty complicated. Okay, we're pulling in lots of things. We're pulling in this ABC method from the if a is equal to 1. We're pulling out factor by grouping, and we have some greatest common factor in there. It's a very, very involved process. But actually, this is, I think, the simplest and most straightforward way to do these. Trust me, I know several methods, and this, I think, is by far the best. Okay, in example 2, we'll do it again. Is there a GCF? 24x squared y, wow, x squared y, plus 34xy plus 12y. Well, first of all, there's lots of variables in that. It looks like there's a y in every term. So that's part of my GCF, is this y. And then the numbers 24, 34, and 12, those are all even at the very least. So it looks like 2y is going to be my GCF. So 2y times what is 24x squared y? Well, 2 times, let's see here, 12 is 24. And then I need x squared so that y times x squared is x squared y. Okay, and then 2y times what is plus 34xy. Let's see here, 2 times 17 is 34, and I already have a y there, so I need an x here. Okay, so 2y times 17x is 34xy. And then 2y times what is 12y? Well, I already have the y there. But 2 times 6 is 12. Whew. All right, so I'm now looking at this trinomial right here. And let's see here, there's no more GCF in there. And the leading coefficient is not 1. So I'm using the ABC method. I'm looking for numbers that are factors of a times c. So 12 times 6. So a times c is 12 times 6, which is 72. I'm looking at factors of 72, and there's lots of factors of 72. So I'm looking for two numbers that multiply to be a positive number. Both must be positive or both must be negative. And they must add together to be a positive 17. So I'm looking for two positive numbers so that they multiply to be positive and add to be positive. So here we go. I have 1 and 72. I have 2 times, let's see here, 36. 3 times 24. I have 4 times, let's see here, 18. I have 6 times 12. And I have 8 times 9. Okay. You can use a calculator for this. You can take the number 72 and then divide by like 1, 2, 3, 4, 5, 6, 7, 8 until you start to get numbers that are close in number to the ones you're dividing by. That'll kind of help a little bit. Now, is there a pair that adds together to be 17? And the answer is yeah. 8 and 9 multiply to be that A times C number, 72, and they add to be 17. All right, so don't lose your GCF. So I have 2y, and I'm going to rewrite this. Well, I have the 12x squared. I'll rewrite this 17x not as 17x, but as 8x plus 9x plus 6. Okay, so I split that up. This term gets split up into two terms right here. And then I do factor by grouping with this 4-termed polynomial. I'll write this as a bracket because I'll have kind of nested parentheses inside, just keep it very clear for me. Okay, so looking at this right here, actually I should just break it up that way so I have the two groups. The GCF of 12x squared and 8x is going to be 4x. Okay, I'm looking at the GCF of these first two terms. 4x times what is 12x squared? The answer is 3x. 4x times what is 8x? And it's plus 2. All right, and the GCF of 9x plus 6 is 3, so plus 3. And 3 times what is 9x? The answer is 3x. 3 times what is plus 6? And I get plus 2. All right. Now, I'm going to pull this common factor, I get the same thing here, to the front of my brackets, and I get my 2y, and I get times this 3x plus 2, and then pulling that out, I'm left with 4x plus 3. Woo! So these are more complicated, okay? But hopefully you've built up the skills through GCF and ABC where A equals equal to 1 and factor by grouping. You've kind of built up all these skills. All right, this video was about factoring 3-term quadratics where the leading coefficient is not equal to 1. Thank you so much for watching.